Hello, this is Ian Vogelsang, and this is the Introduction to Ivy presentation. Ivy is a new block storage synthetic workload generator with real-time dynamic feedback control and a workflow engine. Why did I build Ivy? My long-term goal is to automate performance testing, so we want to be able to have a workflow engine to automate a test suite workflow. And we want to use the dynamic feedback control feature to perform tests in the theoretically minimum time possible. And through a combination of these two, we can substantially reduce test time and test cost. We can improve time to market. We can significantly improve the quality of the measurements that we make, and we can automatically calibrate sales sizing tools. And then the more short-term goal for manual testing is to significantly simplify setting up manual tests. Just say, for example, that you want to test selecting HTTP pool ID equals 0 and 2, and let Ivy figure out which ones on which test hosts you want to use. And then with Ivy, it's very easy to verify that the test configuration that you're getting is really what you intended to set up. You can find out if your setup worked okay. For example, you just say create rollup port quantity 64 max droop 20%, and then Ivy will automatically validate that there are 64 ports reporting and that none of them is showing an IOPS that's more than 20% below the IOPS of the fastest port. So like I said, it's very easy to validate that your test setup went okay. And then another objective is to be able to do things like find the IOPS to obtain 1 millisecond service time. And this uses the dynamic feedback control feature, because normally you impose a workload on the subsystem, a given IOPS, and then you measure what service time or response time you're getting. But with Ivy, you can do it the other way around. You can specify a service time target, and you can dynamically find the IOPS to hit that target, and I'll show you an example of that later. And then finally, when we're making all of these measurements and we're publishing them to customers, by making Ivy open source, then customers can audit the source code, and they can be confident that the measurement results really are what they appear to be. In an initial test where we replicated what we call a scalability test suite, we go through several hundred combinations of input parameters using a standard scalability test tool. For each combination of, for example, reads and writes and block size, for each combination we run for a fixed 6 minutes. That's how we normally do the testing. So I just created an Ivy test suite replicating the series of tests with all the different combinations of input parameters that we normally do to characterize the performance of an array or a drive type or something like that. And what we saw was that the overall test runtime decreased by 60%. And this is because the vast majority of the time the workloads settled down quickly and were then stable, so we didn't need to test for very long. But it turned out that there were a few cases where it took a long time for initial transient conditions to settle down, or that where on an ongoing basis there was an instability in the workload on the subsystem, because of the variation from subinterval to subinterval, we needed to sometimes run for as much as 20 minutes to get an accurate measurement. So the interesting thing here is that the use of the measure feature substantially reduces test time, while at the same time improving the quality of the measurement data. So to summarize about Ivy, first of all, it's written in C++, and it uses the asynchronous I/O interface. This means you get the lowest CPU overhead, minimizing the cost of test host hardware and maximizing the measurement accuracy that we're going to get, because most of the time the CPU is idle. And it's designed for open source and vendor independence. We made it super easy to add support for another vendor, and being open source, you can look at the source code and you can contribute if you want to test something different. And for manual test runs, it's super easy to set up because you can directly select by whatever attribute that the LUN has. You can select by any one of those attributes, and Ivy automatically figures out which LUNs and which hosts those are. Then with the measure feature, we can measure for the minimum theoretically possible time to make a valid measurement to the specified plus or minus accuracy. And then because we have real-time dynamic feedback control of the workload, we can find what IOPS is needed to obtain 1 millisecond service time. And then in terms of producing the quality of the output, we record only valid measurement data. Not only do we measure for long enough to obtain a statistically valid measurement, but we can invalidate that measurement if the test setup didn't have the right number of ports reporting, let's say, and that none of those ports was running significantly slower than all the others. And of course, we've demonstrated automation of a workflow using IvyScript programs to show that we can automate entire test workflows. Thank you very much.